All right, can't be talking about stuff now because it's being recorded now. So anyway, welcome to Monday. Let's see, let me go back to this one right here. All right, let's see, I think we kind of finally caught up to where I wanted us to be. So we're starting 3.3 today, but needed to know if we're good to go with that.
Questions on the homework, I think, that is good. So did we finish 3.2 like all of it yet?
Yeah, I kind of meshed to 3.1, 3.2. We did a little tiny bit of 3.1, and then I moved into 3.2 to do the rest of it here. So as far as lecture is concerned, I think we're pretty good. We finished up 3.2. We didn't get to the application question itself, but we'll get to enough of those throughout chapter. Throughout the chapter here. So want to get to the fun stuff here. So far we have this definition of derivative, right? Based upon the quotient rule and a limit going there. And so the fun part is now to see if we can actually shorten it up. Can we actually just develop some rules? We call them differentiation rules. Based upon this little definition, so we don't have to go back to it each and every single time. That's the whole point here. And so I think this is actually a pretty fun section here as we go through it. Let's develop the rules of calculus. This is cool. Okay, let me see, make sure my pen is working the way I want it to work. And yes.
Maybe you move the bar of the pictures because it's kind of blocking your screen.
Bar of the picture.
It must be us, yeah.
Is that you guys or me? What's up?
No, it's us.
Okay. Okay, I think I can take this off now and set this up. All right, let's jam. So 3.3. What I'm just going to call differentiation rules. All right, I'm going to try to write not as sloppy. How about that? So we can actually get to. So, let's begin with what we know so far. We know the derivative formula, which is this right here. It's the limit as h, I guess we should say h goes to 0 of f of x plus h minus f of x over h. And how important is it? It's pretty important. It allows us to have a slope of a line. Let's say it goes through here, and it hits this little line at exactly one spot like that. Well, hopefully one spot. Boom, like this, touches it, keeps on going. So we can figure out the slope right at a single spot in time as opposed to 2 points that we normally had to do in algebra. It allows us to look at, if you're looking at an object flying or driving, then that allows us to look at the speed of the object or the velocity of the object at one particular spot as opposed to more than one spot. But that's our derivative formula right there. So far we're here. If we want to take a derivative of something, we got to use this formula. We're good? But that's no fun because it's too slow. And so the question is, how do we get this a little faster here? So first things first, let's do it the easy way, and then we'll kind of build up from there. Let's do the constant rule. The constant rule is pretty easy. Let's take a look at it graphically. So if I have this function here, and it's going to be, I don't know, let's say f of x is equal to 3, right? Because it's a constant function. You guys talk to me, or what is the derivative, or what's the slope of that line right there? It's 0, yeah. M is equal to 0. And so remember, slope is the same thing for this one. The slope is the same thing as the derivative. So tell me if you guys agree or disagree. So that means the derivative of this guy should be 0, agreed, disagreed. Yeah, I think so. I think that's pretty cool. Okay. We can also do it theoretically as well. We can actually set up the the formula for it, and we can prove the fact that any constant term, so let's do this here. Let's prove the fact that any constant term will have a slope of 0. And so the way we prove it is we just say this: let f of x equals c. C is our constant term. So then we say the derivative of f of x will be limit as h goes to 0 of f of x plus h minus fx over h. And we're just proving it. We knew it intuitively by the graph. And if that's the case, this will just be c minus c over h, which is, again, limit as h goes to 0, is 0 over h. Everybody good there? So we're just proving it. But 0 over h, 0 over any number is just going to be 0.
Wait, why is f of x plus h equal to c?
Because notice that there's no x inside here to plug into, right? And so f of x plus h, f of, I don't know, anything is still going to be c. Still going to be a constant term. So there it is. Look at that. We got a graphic representation of it, and we actually have a full proof of it as well.
Wait, so we can just pretend that the h at the bottom is not 0, since we know that 0 over anything is 0, no matter what that is?
Correct, yeah.
That's sneaky.
Okay, so let's do this here. So if you want to write it as a rule, two different ways. Let me jump to this one just to finish up here. So if f of x is equal to c, comma, then f derivative of c is equal to 0. That's one way of writing it. The other way of writing it is just to do this. D of dx of c is equal to 0. So there's another way of writing it. Kind of two different notations depending how you want to say it. In function notation, or we call it implicit notation. Okay, are we good there? Let's do the next one. How about this? Let's prove. Yeah, let's do the power rule next here. You guys tell me if I'm going too fast, okay, as well? I get excited about this stuff sometimes. Let's do this here. Let's prove. In fact, let's do this. 1, 2, 3. There's 4 of you guys, right? When is that? Since there's 4 of you guys, can I go this way? I'm going to assign each one of you guys a different power rule. So power rules are like this. We're going to try to see if we can come up with a pattern. We're good? And so x squared or x cubed. In fact, let's do all 4. Whoa. We've got to do one thing first. Can we do one thing first? Do you guys know something called the binomial theorem? Algebra 2. Did you guys study that? It's this little pyramid that goes like this.
Oh yeah, we did, but why would you remember that?
1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10.
Oh yes.
Still works.
Do you guys remember that from like a long time ago?
Yeah.
Okay. Do you guys know what that means, or at least one application of it?
It's like when you expand things out, right?
Perfect. Yeah. So if we were to expand out x plus h to the 5th, let's just say we did expand that out. it would be x squared plus, now we have a 5, not x squared, sorry, x to the 5th. This would be x to the 4th h, right? Now the h is included in here, plus 10 x cubed h squared. Are we good there? Plus another 10x to the 4th h. Sorry, x is going down, h is going up. So x squared h cubed plus 5 x h to the 4th plus h to the 5th. Okay, does everybody see what I'm doing there? Right, because if you were to expand out x squared, right, x plus h squared, it is, we use the same exact pieces. It's just this row right here. Here's your expansion out of binomials. We good? Okay, are we good there? So here's what I want you guys to do. I'm going to go from the back of the room here. So Kate, your job is to do x squared. Find the derivative from x squared. Taya, you get x cubed. Eli, x to the 4th. And x to the 5th for Sadie. Okay, we good? All yours, have fun. And we want to develop a pattern from this. But we got to do each one of those to see our pattern.
We have to do it because I'm learning this. Yeah, that's what I was wondering. I was like, is this what we do? Because you have to write it out. Ew, that's just the derivative. We're just trying to x plus h to whatever you're calling.
Okay, am I doing x? I guess I should do x to the 6th, and I'm going to do x to the 6th. Me?
Why do we have to go that far?
Wait, so f to the
X to the 6th, that means x plus h to the 6th. All right, derivative.
Mr. Roger, can you go back to the triangle?
Sure, sure. Actually, I need to make my triangle too here. So 1, 6, 15, 20, 15, 6, and 1. So 1, 6, 15, 20, 15, 6, and 1.
I don't know if this is right. I don't think it is.
Yeah, same.
Which one do you have on the square? Yeah, the easiest one. Would you don't take the triangle now, just do x. Let's wait. Let's add it. Yeah, it's just like the
and then that would be the answer.
minus to simplify. I think, yeah, that looks right.
Okay. Can I continue with mine now?
Yeah.
Limit as fx x plus h minus that over h. X limit as h goes to that.
Wait, but did you got h? Do you have h in the box? Yeah, so you can just you can take rid of that because it's zero. Because you zero. Because you use a limit.
So we want to keep h as on the bottom.
No, you want to get rid of h all the time. It's just that when it's in the bottom, it's it's exactly that. It's. Then,
Fourth plus h to the fifth plus. All right, there's my expansion form. Are you guys okay? Something close to that in your sheet of paper?
oh my gosh.
So,
Yeah.
in theory,
You just, all ones that have more than, you only are gonna keep, because you're subtracting the first one, the x, the one that only has x, will obviously be subtracted.
it's a test.
And then it's just 6x to the fifth. Wait, not that one. It's.
Absolutely true. Yep, there's that one. So that gets canceled.
And then you just have, and then the one that has only one h is gonna be pulled out to cross out the one on the bottom, and then you just have 6x to the fifth, because all the other ones have more than one h, so they're 0.
That's super cool.
So that means that it's, let's see, if it's x to the, if it's, what did you get? When you have x, and you got 2, you got 2.
You have just 2x.
You have x, wait a second.
Wait, so then. Means you cancel the h on the bottom.
Yeah, because you can call it nature. So if it's x to the fifth, then it's minus. Oh, and if it's x to the sixth, then it's. Okay, so you take, it's 1 less power and the same prime coefficient. What makes it 3?
Sorry, that's my phone.
Oh, but then if you plug into your all the h's cancel.
Yeah.
You just have 4x cubed.
Yeah, because what you have, if you have x to the fourth, your previous, the power of the, like, the not x to the fourth, you have x to the third. And the coefficient is the same.
All right, I am done. And what I got for the derivative was 6x to the fifth. That's what I got.
So it's literally you just take the top of it and how this cube. Yeah.
All right, you guys talk to me. Who is done and all the good stuff here? Kate, you are done. Okay, awesome. So let me go back to the original one here. So I have the function themselves, and then I'm going to have the derivative. And we're just finding patterns. This is all this is here. So x squared, x cubed, x to the fourth, x to the fifth, x to the sixth. What'd you get for x squared?
2x.
Awesome. Taya, did you finish x cubed?
Yes, I'm not sure if I have the right answer.
What did you get?
3x squared plus 3xh plus h squared.
Oh, perfect. Okay. So in that sense there, what's going to happen is all those h's do turn into zeros. Any extra h's are going to go to 0 because now you can plug them in.
Okay.
So then only that little first piece is going to be without an h because h got factored out and canceled. Good there. So 3x squared then.
3x squared is not a h. Once you cancel it with the
Cool. All right. Eli, x to the fourth.
4x cubed.
Awesome. And Sadie?
5x to the 4.
Awesome. And I got this right here. Okay. Bam. This is cool. We're developing some rules here. So now the question is this. If I have x to the n, that's my function. You guys talk to me here. What is my derivative?
x to the n minus 1.
But we probably have to prove that spot, because right now we're just using the pattern we found before. So we want to prove, we want to prove it. Lost my point.
All right. Anybody got some guesses here?
It should be nx to the n minus 1.
Perfect. I go with that. Awesome. So yeah, that the exponent that used to be the exponent now just becomes the product or the multiplier in front. And then each time, notice the exponents go down by 1. So therefore, we just subtract 1 from it. Perfect. We just figured out the power rule. And so really it hinged upon this little fact right here. You guys agreed that it's this little piece right here. It's the fact that the first term, right? The first term gets to stay because h is factored out, and then all the rest of it is just zeros because h gets plugged in as 0. Awesome. Okay, we got that one. So now let's do some.
Wait, can you go back to the one before really quick?
Sure, this one. So let's write it out. Let's write it out as if f of x is equal to x to the n, comma, then f prime of x is equal to nx n minus 1. So that's, again, one way of writing it. The other way of writing it is the derivative of x to the n. Another way of writing it. So those two pieces there. We got some rules. We're developing some rules. This is good. Constant rule is done. The power rule is done. Okay, so now let's do this here. Now let's start adding them up together, because we don't normally just have x squared. In math, right? We have like x squared plus 5x plus 6. That's what we normally have. And so let's develop some more rules. I think after that, we should be able to do some problems here. So how about this? The sum difference. And I'm going to call this a constant multiplier. And let's do one of them. We could do all three, but let's just do one of them. Maybe the easiest one to do. Let's prove.
It's some differentiation rules.
Let's prove the sum rule, and then we'll do the other ones here. So what is the sum rule saying? Seems like it's going to do this here. So we're going to try to prove that if, oh, that's cool what they do. They go like this. They say j, they just take j of x is equal to f of x plus g of x, two different functions. Is that this guy, or if this is true, then the derivative of j of x is the derivative of x plus the derivative of g.
Well, that would make sense since you can take limits into pieces.
Mm-hmm.
You just want to do?
Absolutely, that's exactly what it hinges on. The fact that we can, remember, we can scoot limits in and out of plus signs. So let's prove this. This is the easy one.
Mr. Hunt,
Go.
I had a question.
Yeah.
Let's go back to the previous slide just a second.
Say again, say again, say again.
Can you please go back to the previous slide?
Oh, yep. This one?
Yeah, that one. Thank you.
Yeah, you can walk
Okay, thank you.
Sure, absolutely. Okay, let's do this one, and I think we'll be ready for some cool stuff there. So let's go for it here. So if that's the case, I'm gonna let j of x is equal to f of x plus g of x. So then, again, going back to my definition of derivative, limit as h goes to 0 of So everything goes back to this right here. Let's see if that's the case. Then it's the limit as h goes to 0 of, I think I'm going to put in brackets here, f of x plus h plus g of x plus h minus f of x plus g of x all over h. All right, I think what we can do now, let's see, limit as h goes to 0. Got this big thing right over here now. Can I put the f of x together? I'm gonna go like this and have that guy over here. And then plus g of x plus h minus g of x all over h. Are we good there? You guys talk to me, see if you guys agree here. I just kind of put the f functions together close to each other and the g functions close to each other. And so in mathematics here, I guess first things first is, can I split off the h? Yeah, I can split denominators. You guys agree? I can split denominators if you want to. And then we have this little rule. We got to think back all the way to our limit rules. You guys remember our limit rule says that if I'm going to do it up here. Limit as h goes to 0 of f of x plus g of x is the same thing as the limit as h goes to 0 of f of x plus the limit as h goes to 0 of g of x. I can split limits by additions. You guys remember that from a long time ago in the same classroom. Okay, so with this, I'm going to do two different pieces here. I'm going to go like this, limit as h goes to 0 of this first function plus the limit as h goes to 0 of this second function. Whoa, it went away on me. Sorry, a little chicken scratch at the ends. G of x plus h minus g of x over h. Okay, I was able to split them up into two different pieces. Talk to me, see if this makes sense. Isn't this just the regular old definition of the derivative of f? Isn't this the same generic definition of the derivative of g? All right, that was the easy one. When we get to the product rule, that'll be the fun one to sort of put together here. And so where are we at? 1004. Let's list them here. So that's the sum rule. Okay, talk to me if you guys are done. Talk to me if somewhat interesting, maybe a little bit. I mean,
Yeah.
we're just working with the definition and developing a whole bunch of properties. So initially I actually cannot list them. So let me list these guys first here. So the sum rule, according to the book, and the book does it like this, which is okay. It likes this little notation. I think it's because there's an equal sign there, that's why. Okay, it just says, look, take the derivative of the f, and then we also take derivative of the g function.
Can you explain what d over d of x is again?
That's just a different notation. That's one notation to do it. If you were to write the sum notation is a different one, then you say if, And then you just have to designate like j of x is equal to f of x plus g of x. Then the derivative of j of x is, and that's the other way of writing it. It's called function notation right there. So depending which way. Those two mean the exact same thing. They're both called the sum rule.
It's the adding rule that we, the adding one that we just did.
Difference rule, obviously, let me not write down both types. So let me write down just the way the book has it here. So the difference rule, obviously, is right there. So all we do is we just take the derivative of each of those pieces, just a minus or the subtraction sign between them. There's that one. And the constant rule, what happens if you have a constant that's multiplying? And if you want to, you can do the proof for that one. But essentially that little k there, that k value is just a number, 5, 12, 68, pi, whatever that number is. The rule says I can take out that k value, put it in front, and use it as a multiplier later, but just take the derivative of the function itself.
Yeah, because if you take the derivative of k, it's, and you're doing the h goes to 0, it's just going to be itself, right?
It's just gonna be 0, yeah.
No, but yeah, so if it doesn't matter, like if you just have the limit of k as h goes to 0,
Oh, it just
okay. So that's why we take it out, right?
So the middle one's the subtraction rule and the bottom one's the quotient rule.
Constant multiplier.
Okay.
Cool, you guys. This is kind of cool. We're developing some rules that we don't have to go back to the definition anymore. So,
Hear the wind?
say again?
Can you hear the wind?
No, I cannot.
It's going to be sad.
Oh. Oh no.
Okay, are we good? So exercise 1, finally we get to exercise 1. Find the derivative. All right.
X to the 2. It would not be good to do the but it's fine now. Because
All right, if you want to, you can go the long way if you like, but I suggest you guys do it the easy way.
yeah.
Can you go back to the last one? I didn't write down all of them yet.
Sure, absolutely.
Oh,
It's just, which ones did you not get? Did you get
all of them, but
Okay. The second one is f of x. The second one is f of x equals x to the 10. Okay. The third one is f of x equals x to the -4th, I think. I'm pretty sure that's what it is.
was there a
All right, are we good now?
Not yet, sorry.
No, no problem.
Let's see. Wait, is it? Same as the negative exponent?
Okay, I'm good now.
Oh, wait, that would be.
Perfecto. Okay,
But you just take it 1 over x. Because it's 1 over whatever. If you're taking the things h goes to 0, it would be 1, so 1 over.
all right. Kate, I don't know if did you have time to copy exercise 1?
Yeah.
All right, So if you want to do it the old way, that's perfectly fine. I would not suggest it. To drop it into the definition. I think we could just do the rules themselves, right? So the constant rule says the derivative.
That makes sense.
Talk to me when you're ready here. You guys okay with the derivative of a is just 0? Are we good there?
Yeah.
Boom.
So
Love
if you asked us that, our answer would be f1 prime x equals 0, and then we just box that. Or you could probably say you did the derivative of f of x equals 0. But either one.
Are we good? Sorry. I hear some conversations, don't hear all of them. Are we good?
Yeah. Yeah.
Okay, so A, by the constant rule, the derivative is 0. Awesome. B, by the power rule, the answer is 10x to the 9th. Are we good there?
Yeah.
And the power rule also works for negatives. It's the same thing because it is just... Oh, you know what, guys? The iPad died, so I don't see you guys, but that's okay. As long as I can hear you, I think we're doing okay. So the derivative would be, oh, you went up. Thank you so much.
It's just a little battered.
Able to reach it, Sadie?
Yeah, useless, yes. Can't tell it. No, what's that? Oh my word. Okay, I can't see it. Let's hope it's more.
Can you see us in front of you?
I can see you guys. Yeah, that's cool.
Okay. Probably not Eli as much.
I see like half of Eli, but that's okay. Okay, we're good there. C is all right? That's
So would it be negative? Oh, wait.
Oh, just
Yeah,
negative?
because it goes more negative. Okay, this is
Wait,
we were thinking,
-4 to the -6?
Mr. Hunter,
yeah.
this is wrong, but what we were thinking was you could just make it into 1 over x to the 4, and then do it like 1 over 4x to the 3rd.
Oh, that is so cool. Okay, good job in thinking about it. The problem, this guy is no longer, this guy will have to be a quotient rule on our hands.
What if it, well, I don't understand. What if the quotient rule,
I think we're gonna have to cover quotient rule in just a bit here.
But so then, how does the exponent get
Sorry,
to
Eli,
it?
again?
Because
negative
4 minus 1 is 5.
it's okay, Joy. I thought negative 4 minus 1 was negative 3. Okay.
So then
That's
for
fine, I
negative,
guess.
we just switch it to be negative n x, negative n plus 1.
Yep, are we good now?
No, it's still negative. It's still negative n minus 1 more.
Yeah, but it's always going to be here then.
Oh, wait, why is it negative? Yeah, no, because instead of n minus 1, which would be
It's
3.
just negative.
So if it's 4 minus 1, then it's 3. But if it's negative 4 minus 1, then it's negative 5. Because n can be, it's not negative, it's just n equals negative 4.
Okay, are we good there?
Yeah.
Yeah. On this one, oh, the sum rule here. I should have put a minus rule in here too.
Oh, no, it's 45. 45. Yeah.
This one is going to be the power rule across here, right? But then one of them is actually also it's the sum rule happening at the same time. That little 3 is going to go to 0, so who cares? I don't even need it at this point. Good. We should do one more here. Let me jump in with one more. D, E. E is going to be, since we had a little trouble with C, I'm going to go with, oh yeah, this would be good. How about that one? Now, we don't have a quotient rule yet. We don't have rules for fractions yet. We'll develop those here.
Wouldn't it be 0 over
Oh,
0?
yeah, it would be 0, right?
2.
Because 6 goes to 0, but I mean, you don't know the quotient, so that might be right.
But if you just use the power rule, then you get 6 over 2x.
Oh,
And then you just simplify it, becomes 3 over x.
Oh, that's a good point.
oh, that's a good point.
1 over x.
It would be 3 over x.
Oh, wait.
It's 6 over 2 at x.
I accidentally did.
Before you guys go on, what's the ideas of?
I don't know.
My favorite one.
Yeah.
Let's see. Can we make E look a little similar to C? That's the question. Can we make E look like C?
Oh, yes, because it's 6x to the negative.
I'm going to go with -2. Is that okay with the -2? I'm going to just bring it up to the numerator.
Oh, because you can flip it.
It's the same thing as backwards.
Then we have yourself.
Oh.
Now let's see. -2 comes out as a multiplier, but 6 is already there. Are you okay with the -12 now? And talk to me here. See if you guys agree with me, yes or no.
Yeah.
Wait, what? It's negative
then you-
12x to the 3.
Then you just do the n is -2, so n of x would be 6 times -12, so it's -2.
Negative
Take
2
it to
minus
-12,
1 is negative 3.
So then we get back on the fraction.
Might as well, I guess.
Wasn't that better than when we started with?
It's not,
It's
it's,
different.
it's different, yeah.
Well, I guess what was the function? What's the group?
Okay, are we good there?
Yeah, super.
Yes.
So is that
So we've been dealing, yeah, so we can deal with these guys here with fractions. We just move things up to numerator and we deal with it as a power. Okay, next piece.
I thought he said the derivative equals I don't know.
Well, it is the slope, but isn't it, when you're finding the derivative for the function, not just a point? If you're not filling it, then isn't it just the, wait, I don't know.
All right, are we good? Are we good, guys?
Sure. Yeah.
Derivatives and stuff?
Figure it out later.
We'll figure it
Let's jump to something else now. So far we've been dealing with addition and subtraction this year. Next is let's deal with the multiplication or the product rule. So now the real question is this. If j of x is equal to f of x times g of x, then what's the derivative going to look like? Is it just is it just d of f times g of f? That's it? Or is it just the derivative? And I don't know. I think this we put a little question mark. I think we figure out like let's try to figure out what that's going to be. Okay, putting your thinking caps on, let's go. So if j of x is equal to all that, the derivative is going to be, and let's go together through this here. We might get stuck together and hopefully we get unstuck together.
Wait, this might sound dumb, but what's the difference between product and constant multiplier?
Sure. Constant multiplier is like a number in front. That's just like, you're like 10x squared. There's your constant multiplier. A product rule would be more like this.
So what has to do with the
Oh,
constant
got
that's
it.
multiplied and then
Got
the
it.
function.
Okay, thank you.
Sure, absolutely. You guys, please ask the questions. That's why we're here. This is good.
I'll ask the dumb ones. You guys can ask this for me.
Okay, I think we have it right there. So let's work together. Let's see if we can get something out of this. Okay, if that's the case, then I got myself the limit as h goes to 0 of, let's see, f of x plus h multiplied by g of g of x plus h. And bracket, bracket maybe.
This is longer than
And let me erase this stuff on the side here. Okay, boom. There's that. Divide by h. Da-da-da. And now we're stuck. And this is one of those in mathematics, happens sometimes, is that you get this little brain surge, like, you know, I wonder if, and then you notice we're stuck between the little f of x plus h's and the g of h's, right? And then just the plaino f of x and g of x.
Times. Oh, got it.
Sorry. Thank you so much for helping with my chicken scratch.
Yeah.
That's just as far as we can go.
That
I don't
there,
like this.
and then we're waiting for a stroke of genius. That's what we're waiting for.
We're just redoing
Yeah.
it.
Wait, are we supposed to come up with the stroke of genius?
No, I'm gonna show you what people have done in the past. And here's the little what people have done in the past. Remember how in algebra 2, remember how we were to add something, and if we subtract it at the same time, we technically don't add anything else. It's that little piece there. It's the completing of the square kind of thing. So how about this? Let's add. Here's our little stroke of genius. We're going to add f of x times g of x plus h into this equation, and we're going to subtract it at the same time. Or maybe like this. Maybe subtract it first and add it. That's jam.
You're really funny.
At least with f of x is h.
Whoa, what happened?
Well, we don't want.
Okay. Limit as h goes to 0 of, and let's see how we can add this together. And I'm going to drop the brackets here just so we see it all as one big giant piece. So how about f of x plus h times g of x plus h minus, we're going to minus it out first. So subtract out the f of x, g of x plus h. And then we're going to add it in, same exact thing. It has to be the exact same thing or else we've added something different. Whew, there it is. Looks ugly, but there it is.
Oh. So cool.
Okay, so what do we know? We can, well, I think we can split off. We can split off h's, right? We can split off h's. We also know that we can bring in the limit signs where we want them. So notice the way I wrote it in here. Notice there's the minus signs over here, right? What I'm going to do is I'm going to split it off into two different pieces. Here's my little split that's going to be happening right here. I'm going to stick in the limit into here.
Is that times or wait? What is this add? That part?
There's a minus and an add and a minus. And then
Well,
others
no,
are all times.
in the little bubble. Is that
It's a time.
F of
It's
X
a multiplication.
times.
Yeah.
It's a dot.
G of X?
I would never use a multiplication sign.
That's not an elimination. That's just a zero.
Okay, we're good. Let's see if we can. Now we're going to do it. H goes to 0. F of x plus h times g of x plus h minus.
My brain is.
We're going to split this guy off of this one.
Well, once we have the rule,
Yeah, but this is a shortcut, so let's do this.
Yeah, that's right. Once we develop this shortcut, you don't have to use it again. We'd have to do it the long way. But tell me if this makes sense right over here, splitting these guys off.
Yeah.
And then what's common inside the first limit?
And
Limit is h.
G of x plus h. We can cut that off or cut that out.
Yeah, g of x plus h, it's common. It's here and here. So how about this? We're going to make f of x plus h minus f of x over h. And we're just going to multiply it times what's common. And that little piece is the common piece.
So
All right. Second one, talk to me what's common over there.
now we do that constant thing with that one. Yeah. Based on process. That's not one.
there would be fx.
F of x is common, absolutely. So limit as h goes to 0.
Does that mean multiplication sign?
Percentage.
Well,
That's last.
Okay, I think we're good, so, guys.
yeah, it's just you just made a big difference. Like,
Now we're back to us. It'll be the fx plus h minus fx.
yeah, so we're
But then we have those times
G of x.
g of x and x.
Oh. Those equals 0.
Notice,
Wait, no.
notice with the first limit, notice the h, we only had one h denominator, right? So it had to flow under, it's a multiplier as well. So it had to flow under either the f of x plus h minus f of x or the g of x. Notice there's no h under g of x anymore, or g of x plus h.
Yeah. So,
It's just by itself.
and it's just G of x. So right now we have like f prime of x times, then we still need to get the limit of G of x. We took out the h, which is 0. And then we have f of x on the other. And, oh yeah, and it's just itself.
So if h is going to 0, and I don't need to plug the h in, I can just plug the h in now as 0 because there's no h that is on the bottom to mess with me. So plus, and this is just the proper definition of the definition of g multiplied f of x.
Yeah.
That's cool.
Oh. Those little add-ins and subtractions tricks are really hilarious.
No, I'm glad that I just moved that string of G's.
Okay, so let's
I thought you would have thought it.
let's write this nicely.
Yeah, but why would I give myself that kind of
If nobody else knew it.
Wait, is
then
it-
it makes me
Why
happy.
isn't it
I don't think
F
I
prime of x times g of x plus h? Oh, because h is 0.
Yes, plug in h is equal to 0 into g.
And that's the times f of x again. Why don't we just put the messages?
So off to the side, Kate, just real quick here, just so you have it here. So limit as h goes to 0 of g of x plus h is just equal to g of x.
Okay.
Other little genius idea. Because there's no h to mess with on the bottom, right? We don't need to do all these calculations because it's just g of x plus h.
Times f of x is one.
But then we still.
That is the derivative.
Okay, how are we jamming here? So there's kind of two different ways to write this. Let's go with it here. So the product rule, we have it on the bottom. The way it works out is most algebra textbooks like to write it like this. And we say it's the derivative of the first times the second plus derivative of the second times the first. All good? That's the most common way of writing it.
Are you trying to write that down somewhere, or are you just saying it?
Yeah, no, so let's go back over here. Let's write it down right here as we initially started. So this is the derivative of the first function times the second function plus derivative of the second function times the. We have discovered it. Dun, da, da, da. We have discovered the product rule for derivatives.
I don't have it forced upon us. You know. Okay. But see, it is that you don't need to find out what the derivative of g of x is. That is the derivative of g of x, which is the multiplication of x.
Let's see, 32 after here. I think we're still going. Another way, so that's the common way of doing it here. Some students like to flip this around because it makes sense as well. So let me write it the other way, just see if it makes sense to you guys here. And some students just say this, look, how about if I just take the derivative of the first times the second and keep my f of x as the same?
Why? That doesn't make any sense.
Right there. So Sadie, close your eyes if you don't want to see it. Just kidding, just kidding. You don't have to, really seriously. Okay.
I don't see why you would carry either way, but that I feel like the other one's just it's first, derivative first times second, derivative second times first.
Okay, perfect. Keep it like that.
That was first times derivative second.
Then Eli's gonna confuse you all the time.
What?
What if we just
Okay, so let's jam with it here. So exercise 2. So you guys help me out here. Find derivative. And here's my function. My function is, I'm gonna just call it, I don't know, m of x. M of x is equal to time 7. 5. There it is. Boom. So could we have FOILed this out first, after foiling out, then take the derivative using power rules? Absolutely. We can also take the derivative of it straight like this.
The x to the second.
no, it's
The second.
oh wait. Mr. Andreev, is it 3x to the second or 3x to the 7th?
Second.
Very nice.
Hey,
Okay.
factoring that out wouldn't be that.
Yes, it would be. It would be awful.
It would be easier.
All right, give you guys a minute yourself. Go for it.
And you have to.
Oh yeah, we still have to find the derivative.
That's what I was saying. Is you have to find the derivatives of both.
Yeah, but I'm trying to do, okay, those are smaller than the whole thing. Okay.
Are we doing them individually?
You should do this.
X plus h.
No, I mean, each of the things in the parentheses, you do them separately.
Well, you
Minus,
have to,
or do you
because
have
for the
to
product
do
rule, you need to
this
find the derivative of the first and the derivative of the second.
Over h.
You don't.
We just have to find f prime of x and g prime of x.
Yeah.
So it's, let's see,
And then f prime of x is, then you use the power rule for the
it's
first part.
3x squared plus 6 xh plus 3h squared minus, or plus 4 minus, it's just
Oh, you have to put it in.
minus 4. You have to do it still.
You do in fact have to do the problem.
You sure?
6x, I'm almost done, wait, I'll tell you what it is. Might be wrong, but
See, I like
3, 3, and then we go h divided by, I think it's 6x, I think the
just 6x.
derivative of x is 6x. Is that right, Ms. Rondio?
All right, we'll go for it here. So derivative of the first, this little piece here, 6x, are we good? And that
I probably did the wrong arithmetic because, yeah.
multiply it times the second function plus the derivative of the second function. So derivative of 7x minus 5, that would just be 7. And multiplied by the first function itself. So 3x squared plus 4. Are we good?
Wait a second. Oh, we didn't do it. Oh, wait. How did you get there?
How do you get there so fast?
We didn't, that's not the derivative. He just broke it up, but I don't know why you wanted, wait.
No, he didn't just break it up.
Oh, yeah, no, he didn't.
That's the answer.
Okay, yeah, he did. But how did you do it without solving for f prime of x for the derivative of f of x and the derivative of g of x?
You just do it.
Or just, yeah, he probably just did it not fast.
I can just do it. As long as I know I'm taking the derivative of it.
Okay, yeah, so 7, I just did that. G prime of x is 7 and f prime of x is 6x. So that's right. And then
They just plug it in.
and then we just multiply by f of x. Yeah.
And off to the side, some students off to the side, they'll actually do this extra little step. They'll say, okay, if that is the case, I have 6x here. And so they'll set up the problem so that later on, they're just doing the derivatives. And that is actually a pretty good idea to keep in mind, especially when it gets a little too complicated. All right, you guys, talk to me here. Taya, you doing okay there?
Once we get to that point, do we have to multiply it out? So do like the 6x times 7x minus 5, or do we just leave it?
Sure. Let's see. You can probably leave it. I haven't taken a look at the back of the book for answers here, but normally we just take the derivative, leave it alone, unless we need to do more work with it. Okay, so Kate and Taya, just because I don't hear from you guys as often, how are you guys doing? Is that okay with A?
Yeah, that makes sense. Wait, I'm confused about the initial breakdown from m of x to the derivative. Like you broke everything up. How did you do that?
So we're just using the product rule, right? So we're going to take the derivative of the first function.
Okay.
Here's your first function right here. Here's your second function. And so take a derivative of 3x squared plus 4. That's going to be just 6x.
There's a button that says n derivative. Oh, wait.
Oh.
Oh my goodness. They're kind of amazing. Wait,
It might be hard to
if you plug it into this equation,
Kate, are we good there with that?
Yeah.
and then you do
And then the rest of them stay the same because it's just the second function multiplied first time through, and then the first function staying the same.
Okay.
well, you need to put in what x equals though.
No, you don't, because you're not finding the derivative at a certain point. You're just trying to find.
I mean, you can do for calculation. So we won't need you unless you plug in all the things. So you have to
Oh, where between x, well, it wants you to give
a specific x value.
no, doesn't it want,
You plug in the rest of it.
okay, so it's not actually finding the derivative for the equation for that one.
Yeah.
Well, that's, okay.
But it's not.
So that whole thing in the parentheses. Oh my gosh.
There's a compass
Why?
here.
Where's still that button?
What's the part with the d
Which
over
is
d of x or d times x?
This was just the derivatives. This was derivative of the first function.
Okay, so that's just kind of like showing your work a little bit for that.
Yeah,
Okay.
As these guys get more complicated, sometimes we might just have to use that just to keep things clear in our minds.
Okay. I'm gonna write that down just because I will
Right.
rather do this.
So I just love solving for derivatives 'cause
It's kind of fun though.
it is fun. It's just kind of tedious.
Yeah, but you're the one who said you like algebra.
I do like
That is what algebra is.
It's so much algebra. And it's like four times.
Okay, I got it all down.
Proof.
Yeah,
Just let's see. We have 3 more minutes.
You put it in.
Just one.
Then you have to solve it. It's not like one way to
That's
solve
what
it.
algebra is. It's solving. And you have to figure out how to.
Da-da-da-da-da-da.
I think you're gonna realize that algebra is not nearly as fun as you thought.
Let's go with just one more. Just one more. How about this? F of x plus h is equal to, I'm thinking in your own mind here, just for practice sake. And then we'll start off with quotient rule next time. So what happens if there's a fraction? Let's do this one. All yours, just for practice sake. And then what should we think about is this one right here. Let me put on the bottom here. So if you guys are bored and you're like, oh, you know what? I'm not sure if I could. Class is too easy. If you say that.
Oh, I say that all the time.
Yep. The question is this, can you use the definition to come up with that formula there? F, again, back to definition, right? F of x divided by g of x. We just did the product rule. Product rule is the multiplication of them. Now the question is, how do you do the division of them? There's your next connection. And so we'll pick that up next time here. All right, with time left over, all yours for B. And again, hopefully you'll be able to do it in your head. If you need to do the work, extra work on the side, go for it.
Because you know that it's, yeah, but you can think through it because you know what's gonna get canceled out. Let's see, it's QX.
All right, I'm gonna give you guys what, another 3 seconds, or are you guys done? Raise your hand if you're done. Taya, you done? Eli, you done on this one? Okay.
Why do we have J?
Let's go with it here.
No, that's
So it's good. It's just going to be the derivative of the first one,
which is 0.
x plus 2. So the derivative would just be a 1. Is that right? It's the slope here, technically.
Oh, yeah.
Multiplying the second one plus the derivative of the second one.
And the second one, you don't even have to multiply everything. You just know that the things you care about are 2xh plus 2h squared, because everything else gets handled, and then you just take out h, and then you just add 2x. Because otherwise,
I'm going to go with 4x. Is that okay? 4x.
4x. Yeah, 4x because it's 0.
And then multiplying times the first function itself only. All right, so your trivia homework question is this. That was cool. That was the development of the product rule. How do we develop the quotient rule? How do we develop that one?
Okay, this is homework.
You can use it. So if you're bored, go for it. Or we could just wait till Wednesday and we'll cover it then.
So is the quotient rule is also in 3.3?
Yeah, it is still also 3.3. And then we're going to deal with, so I've got quotient rule, and then we have functions in general. How do you do functions in general? Combining functions, combining the quotient and the product rule, and then some application questions.
So tomorrow or on Wednesday we'll finish 3.3,
Yeah,
and then we can do the homework for that.
Yeah, and we didn't cover quotient rule, so if you see fractions, you can do fractions. Otherwise, you can do the rest of it.
Okay.
Cool. All right, guys, thank you so much. Hopefully that was fun. Hopefully that was enjoyable and learning. All right, and you guys have a good rest of the day.
Thank you.
Thank you.
Right. Log off so the recording can start processing.
Kill them. Or is this rank just keep it? I like this better than
Oh, that's right. Kate, I don't know if you can
Yeah.
slow down the desks that you, just the two.
Oh, yeah, I can do that.
Oh, thank you, Sadie, so much. Got it already.
Or,
All right, you guys. See you guys on Wednesday. Bye.
I.
I know, I'm so sad. I got it right at the end. Got it right, like the week we closed. And I was so sad. All on the